Hello and welcome to the notes on completing the square. The reason we learned to complete the square is so that we could solve quadratic equations using the square root method. So let's review a couple of types of problems that we did last chapter. So the first one says solve using the square root method. So x squared equals 48. In order to get x by itself, if it's being squared, to undo that, I square root both sides. So on the left, I'm left with x equals, and anytime I have to physically take the square root of something in an equation, you always have your plus or minus and then square root of 48. As always with a radical, I want to make sure that this is simplified, so I'm going to break it down into primes. 48 breaks down into 2 times 24, 2 being prime. 24 breaks down into 2 times 12, 2 is prime. 12 breaks down into 2 times 6, this 2 is prime. And then 6 breaks down into 2 times 3. Both of these numbers are prime. So as you should recall from last chapter, the reason I break it down into primes is because I'm looking for pairs of numbers. So I have 2 2's right there, 1 gets out. I have 2 2's right here, 1 gets out. So the two numbers that escape get multiplied together. So I have plus or minus, I can't forget that, 2 times 2, which is 4 square roots of, I look what's left over, there's a 3, there's no other number. If there was, I would multiply them together. There's not, so it's just x equals plus or minus 4 square roots of 3. This next example that we have looks a little bit different because it's not just my x that's being squared, it's a whole quantity, x minus 3, that's being squared. But regardless, my goal is to get this thing that's being squared, which in this case is x minus 3, I want to get that by itself, I want to isolate it. So I'm going to subtract 5 from both sides. I'm left with x minus 3 quantity squared on the left side equals 81 on the right side. Now that I've isolated my squared term, I take the square root of both sides. Squaring and square rooting undo each other, so on the left I'm left with x minus 3 equals plus or minus the square root of 81. Hopefully you see that 81 is a perfect square, so I have x minus 3 equals plus or minus 9. Next up, I add 3 to both sides, so I'm going to end up with x equals 3 plus or minus 9. Notice I did not end up with plus or minus 12. It's 3 plus or minus 9. Those give me two nice answers. 3 plus 9 is 12. 3 minus 9 is negative 6. And I'm done with that problem. Okay, so now that we've reviewed how to solve by square rooting, we are going to solve a problem using the square root method. Now if you look at this quadratic in example number 1, it says x squared minus 10x plus 25 is equal to 27. If you remember from last chapter, the only time you could use square roots is if your equation has only an x squared term, no x, just like the first example above, or if you have a binomial, meaning two terms inside the parentheses separated by addition or subtraction, that's squared. So looking at this problem, it has an x squared and an x, which isn't the type of problem that we're just could go ahead and start square rooting both sides and solving for x. So therefore, completing the square, what that is a way to rewrite this problem so that it is a problem that we could take the square root of both sides. Now, in this trinomial on the left, this constant number, this one that doesn't have an x attached to it, that's the number that's really important. That's going to make us be able to rewrite the left side so that we could take the square root of both sides. Now, that number has to be very special. And the way you get that number is you take b, which in our case is negative 10, divide it by 2, and square it. And that's the number that should go in that spot. So what we would get here is negative 5, and if I square it, I get 25, which is the number that I have there. So because I want my constant term on the left side to be 25, and it is, then I'm ready to factor this left side of the equation. So we are looking for two numbers that multiply to be 25 and at the same time they have to add up to negative 10. Well, those are negative 5 and negative 5, so I could rewrite the left side as x minus 5 times x minus 5, and that equals 27. Because I have x minus 5 times x minus 5, I could rewrite this as x minus 5 to the second power, and this equals 27. Now that I've written it this way, hopefully you see that what I've done is I've made this problem look a little bit more like the example number 2 from above, where I have the thing that's being squared. It's isolated, it's by itself, so now I could go ahead and take the square root of both sides, because taking the square root of a square undoes it, leaving me with x minus 5 on the left side, and that's going to equal plus or minus, don't forget that plus or minus, square root of 27. So over to the left here, I'm going to go ahead and simplify square root of 27 because we always have to simplify. This is 3 times 9. Circle the 3 because it's prime. 9 is the same thing as 3 times 3. Circle both of those 3's because they're both prime. And it takes 2 for 1 to escape. So what I'm left with is x minus 5 equals plus or minus 3 square roots of 3 instead of square root of 27. My last step is to add 5 so I could get x by itself. And when I do this, I end up with x equals 5 plus or minus 3 square roots of 3. Notice that 5 and 3 square roots of 3, they're not like terms, so there's nothing that I could do to simplify those. That does not equal 8 square roots of 3. It doesn't equal 3 square roots of 8. The 5 just hangs out in front and cannot be combined with 3 square roots of 3. Alright, moving on to example number 2, we have x squared plus 16x minus 9 equals 0. So I want to solve this by completing the squares. So again, what I want to do is check if this constant term is what I need it to be. And what I need it to be is b, which in our case now is 16, divided by 2 squared. 16 divided by 2 is 8. When I square that, I get 64. Hopefully you notice that the constant in my problem is not a 64, it's negative 9. So what that means is if that constant isn't the number that you need it to be, and again, the number you want it to be is b, which is always the number attached to x, take that divided by 2 and square it. You need that number with the x's to be that special number. And if it's not, what you do is you get rid of the constant that is there by moving it to the other side. So in our case, I would add 9 to both sides. And so I would get x squared plus 16x equals 9. Now I need to add in that special number that I said. And so it's 64, and I add 64 on this side. But hopefully you all realize that I cannot just add something to one side of an equation and not to the other, or not do anything to the other side. Equations have to remain balanced. So whatever I do on the left side, I have to do on the right side. So I'm going to add 64 to the right as well. Now I'm ready to factor the left side, so I'm looking for numbers that multiply to be 64 and at the same time they have to add up to 16. They are 8 and 8, so x plus 8, x plus 8. Hopefully you're seeing a pattern too, that it's always this number. This b over 2 is the number that appears twice. So whatever you get as b over 2, that's going to be your number that appears twice in the parentheses when you factor. So now 9 plus 64 is 73. Rewrite the left side as x plus 8, quantity squared, equals 73. Okay, now that I've isolated my binomial that's squared, I can square root it. Squaring undoes square rooting, so x plus 8 is going to equal, now 73 is prime, so it doesn't break down into anything, so it's plus or minus the square root of 73. Subtract 8 from both sides, and you end up with x equals negative 8 plus or minus the square root of 73 is your final answer. Okay, so number 3 says it's a stop problem, which I know is the ones that you guys pause the video, try on your own. I'm actually going to pretend that the stop sign is down below where it says one more. We're going to do example 3 together, and then example 4, well, it's not numbered number 4, but that one I want you guys to try on your own. So again, what we want to do, we're checking if this number is that number we need it to be. You take the value of b, divide it by 2, and then square it. So I would get negative 7 squared, which gives me 49. 9 is not 49, so I get rid of it by moving it to the other side. So x squared minus 14x is going to equal negative 9. Now 49 is that magical number that I add here to the left. I can't just add it to the left without adding it to the right, so I add it on the right side as well. Whoops, 49. So on the left side right now, I am ready to factor this trinomial. I look for two numbers that will multiply to be positive 49, but at the same time they have to add up to negative 14, so they are negative 7 and negative 7. And again, like I said, if you remember, this b over 2 is always that number that appears twice, and this is going to equal negative 9 plus 49, which gives me 40. Just as before, we're going to take the left side and rewrite it as x minus 7 squared. This will equal 40. Now that I have my squared piece isolated, I take the square root of both sides, squaring and square rooting, leaving me with x minus 7 equals plus or minus the square root of 40. Off to the side here, to the left, let's simplify the square root of 40. This is 2 times 20. Circle the 2 because it's prime. 2 times 10. Circle the 2 because it's prime. And then 2 times 5. Circle both numbers. They're both prime. Look for pairs of numbers. I see a pair of 2's here. One gets out. And these two numbers have no partners to help them out, so they have to stay underneath the radical sign. So I have x minus 7 equals plus or minus 2 times the square root of, multiply these two numbers back together, it's 10. Add 7 to both sides, and we end up with x equals 7 plus or minus 2 square roots of 10. And that's my final answer. Okay, so like I said earlier, this last problem is the one that I want you guys to stop the video, try it on your own, and I will display the answer so you can check if you did it correctly or not. Okay, so the answer that you should have gotten for this problem is that x is equal to 4 plus or minus the square root of 10. Now I noticed as I was writing this answer down that none of these examples had complex answers, meaning i's in the solution. On tomorrow's classwork, there will be I values, and that happens when you get a negative underneath the radical that you have to take out then and get an I on the outside. Okay, so that's it for completing the square. If you didn't get this last example right on your own, please make sure that you ask your teacher in class tomorrow so that you figure out how to do it. All right, thank you so much for watching and have a great day. Bye.